Okay, hello everyone. My name is Nenad Lasković. I'm sure that you're either using Scrum or some variant of it, or you're familiar with Scrum in general. My idea today is to explore with you why we are using Scrum in the first place and how to achieve its full power. But before all of that, I would start with a bit of a history lesson. The year is 1944. In the Allies are advancing on all the fronts. The tide of war is shifting, and our story takes place in Pacific Theater, where the Allies are frog leaping from one island to another on their way to the Japan's mainland. Many of those islands are really small. They don't have ports, airfields, so the only way to provide supply is either to build the temporary airfields or to drop the supplies by parachutes. At the same time, many of those islands are inhabited by the bands of hunter-gatherers. Can you imagine their surprise? One day they were living not much differently from their ancestors thousands of years ago, and the second day they were fast-forwarded to the 20th century to do all the marvels of our technology. One of the islands is Vanuatu over here, and that's where one of the bases was established. And the native people actually enjoyed all the riches of the modern world. They called all of material things by one word, cargo. As the front moved, the soldiers abandoned their bases, and they moved forward as well. So the native people were once again puzzled. Okay, here we are back to the old days. How can we get hold of that cargo again? One of their chiefs had an idea. Clearly, the soldiers were communicating with gods, and the gods fulfilled their wishes, and they sent the presents by the big metal birds, or they just dropped them from the sky. So the only thing that they needed to do is to do exactly the same, just communicating with the gods, and they will get the gifts. So that's what they did. They built airplanes out of wood and leaves and waited. Nothing happened. The night fell, and they built signal fires and waited. Nothing happened. So this story was a really great example or opportunity for anthropologists to first-handedly explore the birth of a new cult. And you can guess the name of that cult, cargo cult. So the cargo cult became a nice metaphor for rituals without understanding the underlying causes or meaning of the things. And these cargo cults persisted long after the Second World War. It's not that all the rituals are bad. We are all washing our hands without thinking, but if we need to, we could explain why we are doing that. Also, please, this is not the story about the primitive native people. This is a metaphor for the reasoning error that can happen to all of us. Back to the present. So here is one of the rituals performed by many people in this room around the globe. And it's called, even in the Scrum, it's called a ritual. It's a stand-up meeting. Is this a cargo cult? No, they're serious. They know what they're doing. They have all the stickers on the board. That's a regular daily meeting, so obviously it's not a cargo cult. By the way, this one is called a stand-up meeting. Have you ever thought about why it's a stand-up? Why we are standing during it? Concentration? One thing? Time? What do you mean exactly by time? Somebody said time.
Well, for example, if you sit, it's most likely that you will speak about things that you should not speak on a daily stand-up meeting.
All right. So you will be shorter, basically. Okay, yeah, that's basically the idea. If you are standing, we'll be more focused on it. That's well, maybe closer together. So this is not a cargo cult. Are we okay with that? How about this one? I don't know, have you seen it? This is a plank meeting. The team here realized exactly what you said. Their meetings are taking too long time, so make them harder physically and let people doing the planks. I don't know the results, but I don't know. What do you say? Is this a cargo cult? All right, we can discuss that. So a step back. Why Scrum? Why we are doing Scrum, or when I say Scrum, basically Agile, Kanban, whatever, but we are doing some sort of it in all the companies. And I think that Agile has won right now. Nobody's doing waterfall almost. So if your answer is yes, everybody else is doing that, for me that's just another way to spell out cargo cult. So that's not the reason that everybody else is doing that, or at least it shouldn't be for me. So I would like to hear from you guys, what are the reasons to use Scrum, or why do you see the benefit of using it? Organize? Flow, okay. Anybody else?
This might not be entirely clear in the beginning, or you can make better decisions if you make them later on.
Okay. Usually I can predict them. Sorry, I don't have yours on the slide, but transparency, it's along what you said. Basically, everybody has the same understanding. Also, improving communication. Yeah, that's it. We start together, we discuss what we're going to do. But the last one, I think, is the most important one, the efficiency. I think that's what sold Scrum to the management. It was music to their ears, because you can easily translate efficiency to money. Yeah, so if you want to be efficient, Scrum says, okay, maybe that's the goal. But can you put the number on it? How much more efficient will we be? And compared to what? And here's the promise of Scrum. So doing twice the work in half the time. That's a pretty bold statement. I'll get there. So, and it's not mine, actually. It's by none other than co-creator of Scrum, Jeff Sutherland. By the way, now there is a, that's the title of his famous book, and which was translated to Serbian. I read it in English, so I don't know about this one. So if this is not amazing to you yet, a simple math will transform it in doing 4 times the work in the same time. So what do you think about that? I know that I share that with my colleagues, even people that are doing Scrum for a long time, and they were like, oh, wait, do you have any proofs for that? Do you really think that we can do 4 times the work in the same time? But the catch here is, what's work in this sentence? What does it mean? What's work? So I would like to define that first. So what is our work, or to say our goal as software developers or companies doing the software development? So let's start with something more familiar to all of us, not only software developers. So if we say a baker is making bread, what will be the sentence for a software developer? Your thoughts? Code? Code, okay, that's one. Anyone else?
Making bugs.
Bugs as well, okay, okay. We would be out of the job without bugs, I guess. So features, somebody said features? Okay. Somebody. All right. Preaching to the choir. So if you're saying writing code, that's like making dough. It's a building block. It's not the final product. And what Lars said, I hope that you are not judged by the lines of code, because that's a really poor metric. So we take the code and we create features, which is similar to breads and cakes. So we create something out of it. But I would agree with you, that's not our final goal. Our goal is to solve user problems and create value. So for the baker, that's how all of us should see it. I guess so. I didn't get into software development to write code. At least that was my story. So somebody at this point would usually ask, how about money? And I would agree, but money is kind of a consequence of us creating value for any job. So it's not the reason why we are doing this. We could create money in different ways, but that's why I said software development. Sorry? All right, so if you agree with that, we are creating value. Basically, that's our goal. So then the next question you can anticipate, all right, how are we going to measure that value? Calculating the lines of code or number of features is easy. It's really simple. But how do you measure value of a product or a feature? My dear colleagues, okay, let's have an example here. I'm pretty sure that you are all using Word or some other word processing tool. And here are the two sets of the features. The first one is known to all of you, I'm pretty sure. And yeah, I don't like the show of hands, but I would be really curious whoever used this one. So which one? All right, but it's available on Mac and all of that. So the question is, which feature is more valuable here? And I think that's the easy answer. The first one is more valuable. How do we measure that? Which one do you use more often? Or if you were to buy product A and product B, which would you pay more? Or to put it another way, for your, as a software developers, if you are to develop Word from scratch, which set of features would you develop first? And now the bonus question is, which one is more technically complex? And is the relationship between value and the underlying lines of code or time and effort needed to develop it? So that's our next thing. Is this the relationship? We have here features, or like sum of all the features, it's the scope for one product. And on the y-axis, we have value, which hopefully translates to some other measurement like money. So can we say that that's a linear relationship? By adding more features, we are proportionally increasing the value of the product. Yeah, I see that we are on the same page here as well. So the relationship, it's more like this one, like this graph, where the small subset of features are responsible for the most value of the product, while adding the rest of them, it's kind of a marginal increase in the value of the product. The things can be even worse than this. So can you think about example when adding features actually decrease in the value? All right, thanks. So basically, we all know some applications that had really confusing UI with so many things that actually are hurting us. Yeah, please give me just the bold, italic, and underline, and don't bother me with all other things. So coming back to our question about increasing the efficiency 4 times, here it is. And you can recognize that by the different name, Pareto's principle, where you have 20% of the features, it's contributing to the 80% of the value of the product. So why is that 4 times? Basically, we could stop at this point and not do all of the rest. And for the 20% of investment, we get 80% of the value. So that's that 4 times increase in the output. But there is one underlying assumption that I didn't mention and that it's present in this graph. Can anybody point to it? Thanks, that's it. I'll repeat it for the mic. So we should know upfront which features will be those features creating the most value. So the answer is easy. We create only the killer features. We don't bother with features that nobody uses. And we have a solution for that. It's called a crystal ball. So we take a crystal ball, and it's easy. We know what we need to develop, and after that, everything's golden. Unfortunately, yeah, I searched no one on Amazon. So by the way, have you thought about it? Why is it so hard to predict which features will be successful? We know from experience so many companies, some of us tried doing startups, getting rich and now doing the presentations, that this is hard. But what's the underlying reason for not being able to predict future in this case? I would say that we are working in a domain that it's not complicated, it's complex. What I mean by that, I won't go into theory too much. There are a lot of ways to classify the systems, but this one will serve the purpose. It's pretty nice and easy. All the systems can be classified in 4 different categories or domains based on their predictability and on our understanding of the systems. So I'll give you examples to make things easier. As you can see, I like bakery things. So creating a cake, as simple as a cake. So it's predictable, we know what we need to do, and almost every time the cake, if you follow the recipe, will be successful. Building a house, it's complicated. Why? There's so many things going on when you're creating the house, but it's predictable in a way that people done it before, and if we follow some standardized approaches, we will do that pretty okay. Creating software, it's complex. Why is that? Because there are so many interdependent parts that are interacting between each other, and it's almost impossible to predict how that will develop. And chaotic systems are like stock market that are totally random, and then we don't have a way of predicting what will happen. So for the complex systems, we sometimes get the pattern, but in retrospect, not going from the beginning. So now that I'm talking about complicated and complex problems, how we solved each of these. So for the complicated problems, we break them down to smaller tasks or smaller parts, where each of those parts become a simple problem. Also, what's important, we know for each of these parts their relationship, and we can order them. If we are building the house, we know that we can start with foundations. We're not starting with windows. After foundations, we'll do the walls and so on. Not only that, we know which parts can be parallelized, like plumbing and electrical work. These two things can be done at the same time, and we are fine. Also, we have a pretty good knowledge about building or installing certain types of windows. So we can estimate that based on the previous experience. So it's standardized. We have a pretty good knowledge of that from the previous work, and we can do that. So we plot a graph like this, which is called, by the way, how does this look like to you? I think that's I'm hearing a waterfall. Yeah, that's a waterfall graph. So that's why the name came. All good and candy. How about the complex systems? How do we solve complex problems? I'm expecting here somebody to say, Nenad, is this a really complex problem? Really? My 7-year-old can solve this in a few minutes. This is not complex. And I would agree with you on this slide. But how about this slide? If you're standing in the middle of the labyrinth, can you really predict or plan your path through it? Like, I'll take left, I'll go straight, I will go right, and I'll reach my destination? Right. You won't. How do we solve this kind of problems? You know it? I want to hear. Thanks. Trial and error. We are doing trial and errors and basically learning on the way. At the end, the pattern might emerge, but we don't know it while we are in the thicks of the problem.
It's a simple way how the children learn new things.
Trial and error, yeah. Instead of saying, do this, do that, try yourself, and yeah, for some types of problems.
Well, for solid labyrinths, you have a simple way. You just follow the left wall and
I knew it's a software conference, but I couldn't find a better, better example, more easy to explain. So this trial and error approach can be described by this inspect and adapt feedback loop. What do? We start with a hypothesis. I'll take left. We check that, inspect, and if we ended up in a dead end, we say, okay, our hypothesis was wrong. Let's take right. And we go through these iterations as long as we don't get out of the labyrinth or we solve our problem. So this process is iterative. What does it mean? It's basically, we need to repeat it several or many times in time to reach the solution. So compare this to the waterfall. With waterfall, we knew at the very beginning how we're going to solve that. We can estimate this is going to take that much time with some boundaries, but with the really complex problems, you cannot do that. You don't know how many iterations you will need to get to the solution. And there where the Scrum comes in. By the way, this is the quote from the Scrum guide, except my recipe part, a framework to address complex problems. So Scrum was designed to operate in the complex environment because there is no one single solution for all complex problems. You have to find solution for your own problem. And Scrum is here to guide you toward finding that solution. For me, that's a really important point because I think that most of the critiques of Scrum do not realize that. Scrum, it's not about recipe or solution. Once again, it's just a framework to help you think along how I'm going to find this solution for my problem.
You sold something else. You sold to the management. You sold efficiency. You did not sell to this.
I'm getting there.
Also, some big companies, worldwide companies, have another way how to solve complex applications. They take feedback from their customers, from their clients, and after every feedback, they create.
Have you seen my presentation before?
What?
Have you seen my presentation before?
No.
Cheating. All right, so we are getting to all of that. I see that there are a lot of people thinking about along that. So, sorry, I don't know. What are the two main problems or challenges when creating the software products? The first one is, are we building the product right? So basically, this is a technical challenge. So is the product scalable, fast, reliable, all those things that are solved in the technical domain. And Scrum can help us with that. But even more importantly, the question is, are we building the right product, the one that will create value for our users? Both of these challenges fall inside the complex domain, and Scrum can help us with both of them. Let's start with the tech problem. So I mentioned before, why are the software solutions complicated? Yeah, so many parts, libraries, we don't know how they're going to interact, we cannot predict. Also, everything is changing so fast, so something that works one day might not work the another. So yeah, it's complex. And the way to solve that is the following version of the inspect and adapt, known to all of you. Basically, we code, we test, and when we encounter bugs, we fix them, and we repeat the cycle. So this part of the inspect and adapt was easily adopted by technical teams. They love that. Of course, it makes sense to test and integrate early in the process because that addresses the risks early, so we know that what we are building is solid. We can continue from there. My question for you is, who is responsible and what we can do as a product team to ensure that we are building the product right? Whose responsibility is that?
Product manager, product owner,
Product owner, you say? Anybody else?
project manager.
Project? I don't have too much to add. I would say self-organizing team. I think that the whole team should take the ownership of that, and here is why. Who invented unit testing, continuous integration, continuous delivery? Sorry? Engineers. So people inside the team improved the process and find the better ways. We were those people knowing the best what are our issues and problems, and we were trying to solve that. So all those nice things that you have right now and that I recommend using it, started inside the self-organizing teams. You could do that without Scrum, no doubt about it. But the Scrum kind of reminds us to take a look from time to time on the process itself, not just to continue coding and delivering things, but yeah, even daily or twice weekly, stop and think, can we improve the process? You know, we are having too many bugs, what should we do? Maybe automated testing is a good idea. So this part is something that really the team is responsible. Yeah, somebody will say, okay, I work in an outsourcing company. We don't have a saying in how we're going to do that. I work in an outsourcing company, and we don't ask our clients, are we going to do unit tests or not? That's our craftsmanship. So basically, yeah, we are not doing that in any other way because we are professionals. So that part is kind of easy. Usually it's pretty well adopted in most of the teams. Teams are creating the products right. People love to code, they like what they're doing, so that will be okay. how about the other part of the equation? Are we creating the right product? So once again, we are in a complex domain, and sometimes it might feel that we are gambling. Why? We are trying to predict how our features and products will be received in future. And there are so many things that can impact the success of a product. Market trends, competition, government regulations, and for most of them, we don't have much control. So we cannot do much about it. So our ideas are at the end only hypotheses, or some company calls them bets, because that's what they are. We can do all the market research, analyze competition, do user polling or whatever, but at the end, those things we cannot know with certainty. So is there a way to improve our odds if this is a casino? Obviously, yes. And that's the feedback loop that you mentioned. So before committing to the long-term investments and plans, let's try to validate our ideas as quickly and as cheaply as possible. So we start with some kind of prototype. We have our hypothesis, build a prototype, call it MVP, run it with the users, collect the real measurements of their behavior, and then use to improve your product. So once we know if our ideas are valid, we can then continue development. The most important thing here is that we are not relying on opinions and guesses. You know, my boss said, or somebody knows the best. We are using the solid metrics or measurements, and we can back that up kind of scientifically. So let's have an example. So if you're doing this right, we can decrease this cycle to, instead of doing that once or a couple of times a year, to doing it every few months or even several weeks. So we start with a hypothesis. How do we do that? Usually business will explore some opportunities and say, okay, this is the feature product that we want to build. Let's break that down into smaller parts, and we create our backlog over here. This is a real life example. I'll say later where it is from, where there is an application, and there were some blue desktop and yellow mobile features. You can guess by the look of this drawing that the underlying hypothesis for this one was that most of the users will be on the desktop application. The next step is for the business and the technical teams to sit together and to assess what's the complexity of these features and that's what's their expected value. So if two features have the same expected value but different complexity, the obvious thing to do is to select one that is less complex and do it first. So we prioritize the backlog and say, okay, based on the expected value and their complexity, we are putting on the top features that are having the best ratio between the value and complexity. Okay, the next thing, we need to produce a product increment that brings value to the users and that we can use to validate our underlying assumptions. So let's assume that we can do 5 features in the next iterations, and these are the 5 features. So we are saying this is what we're going to deliver to the users next. The next question from the technical team is to ask dear business, tell us how we're going to measure that we are achieving what we want to achieve. So we want to achieve some impact, let's say more users, higher revenue, people are using the application for a longer time, they are sharing with friends, whatever business finds useful. What is that? Spell it out, and then say how we're going to measure that. Agree on how that will be measured, and with these 2 things, we are building this. This is how it's going to be measured. The technical team has information to build that stuff, and so the measurement must be part of the increment as well. So the engineers will do their magic. They will create an increment and give it to the users. Now we are in the inspect phase. Now we are collecting the measurements from the field, and we can present that to the whole team. In this case, we said the hypothesis was the most of the users will be using the desktop application. So we are measuring the number of users using desktop and mobile. Not surprisingly, the graph looks like that the number of desktop users is declining, while the number of mobile users is growing rapidly. This is not a big surprise these days, but this is example from a few years ago, and I think it's just good for illustration. So we get this. Once again, we have measurements. It's not an opinion. I'm thinking the desktop is better or that mobile nobody will use. I really have a measurement. So the whole team goes back to the adapt phase, where they look at the remaining features in the backlog, and that they need to have a discussion right now. Are we going to continue like we were doing before? Are we going to continue with the previous plan? I don't think it's a good idea. So let's revisit the backlog, knowing what we learned in the inspect phase, and the new backlog will look like this one. So obviously, we have to put more effort into developing mobile solution. So what are the benefits of this approach? First of all, we are not wasting our effort, money, and people on things that won't be used. And the other thing equally important is that we are faster to market. If we were to develop, even if money is not an issue, if we go through the original backlog, it will take much longer to get to the features that are really needed for the users. So the same question like before, whose responsibility is to ensure that we are creating the right product? I would agree that it's everybody's, but in this case, it's not equally divided, I would say. In my opinion, it lies more on the business side, but that does not mean that the technical team or development team does not have any say in it. So how I see the things is that we should all share the ownership of the product. It's okay for technical team to question the product owner, business, or whomever, and also if they just get the backlog, they should ask, okay, what's the impact that we are trying to achieve with this one? Put it as a sprint goal. We try to increase I know sometimes it's hard. This is a simple example just for here, but we want to increase the number of users by 10%. And put a number on it. So we know what's the impact and how we're going to measure it, and we know if we reach it or not. So then the whole team can experiment, kind of hey, if this is the impact that we are trying to achieve, why shouldn't we try this or that? And then validate. That's it. And at the end, the hardest, maybe it's a holy grail, nobody's there yet, but the whole organization needs to be agile. So if only the development is agile, this is only a small part of the overall scheme of things. Things are too slow if you're waiting several months for your sales or marketing, and then you have to work on something that you get from them. So this brings us to the end of my presentation. I wish you something that I wish to myself. Please don't be a cargo cult if you can make it. Thanks, and yeah, I'm open for questions.
So towards the beginning of the presentation, we were talking about what features give the most value, and you proposed that one potential answer to that is those that are used the most often. But there are certain features, and I try to fit this into that framework of thinking, and I often don't find a satisfactory answer, that are not used that often and might not even add that much value to the typical user, but unless you have them, it's a no-go. So legal compliance, or for example, building a bank system, you have to have the option to freeze somebody's account, and hopefully that happens extremely rarely, but without it, you know, the system is not usable. So how do we square features like that into this idea of used most often or add most value?
Yeah, thanks. As usual, people say in this situation, great question, and it is. So how I see those things, yes, you have sometimes GDPR. You have to comply. So For me, if you want to go even deeper, it's tackle the riskiest parts first. Sometimes the riskiest part is technology. Are we going to pull out, we want to build something that needs to be really scalable and serve like 10,000 concurrent sessions per second. So that's the riskiest part in your case. If you're a bank, yes, then regulations are the riskiest part. So then they have the value. Maybe it's not the value like in the case of the Word, but it's still the value.
Also, you forgot security officer as a main role in digital area, in IT. Security
Are you the security officer?
Yes.
Okay, then I know where the question comes from.
Part-time on my job.
Well, we can talk about it. Luckily, in projects that I work on, we don't have that much connection with the security officer.
Also, I was involved in GDPR.
No, sorry. Sorry. Oh, yeah, if you can, I'll repeat. So the question was, can you please give to the lady no. So the question was, what's the role of the security officer in the product development? And once again, it really depends on the product, I would say. So is that a riskiest part of your application or one of the riskiest parts? Yeah, then definitely.
Could be one of the stakeholders, definitely. So if the product owner is there part and you are part of the organization, you are one of the stakeholders to a product.
Okay, so from the back we got a comment. Yes, the stakeholders are there. What I want to say is, in my experience, for me the main takeaway from this session is that we have two kinds of problems where you can implement the feedback loop. The first one is technical, and that's usually the first thing that people think of when they're thinking about creating software products. But the second one, creating value, it's harder. And somehow what I see in many companies is that that's how divorced from the technical teams. So technical teams will just get the list of requirements and they're expected to do that in an iterative way. For me, that's really not the way to get the full potential out of the Scrum. So if you need, security officer, stakeholders, but they shouldn't be separated from the development team, and team needs to have ownership and at least, what's the great quote? The team of missionaries, not a team of mercenaries. It's not mine. It's Marty Kagan. Anyhow, if you're just missionaries, you don't care what you're building. And for me, that's the worst thing that ever happened to any of us. You should be really involved in how the product is created. Yeah, the long answer. Anybody else? Okay, that's all. Thanks. See you around today and tomorrow.